So this is a recording, a very long and boring one, when I basically just it shows how I did when I built the MIDI Lightboard into its enclosure, including the LED strips. And what I started with was the plastic black enclosure for the actual controller. And the first thing I did was to make a hole cutout in the lid for the LCD display. Now I'm speeding up the video by 10 times the speed. You can see I do that very often. This was the best way I could think of to make this cutout, as I didn't have any appropriate other tool for it. No kind of saw or any Dremel-like tool that would... I mean, this tool is Dremel-ish, but it's... I tried using the cutting, the discs that come with it, but it just wobbled and didn't seem to cut very straight, so I just went with drilling. You see how I did. I just made holes around the rectangular marking there, and now I'm just cutting up the walls between all those holes and making the cutout. And of course the plastic melts and sticks to the drill, so I have to cut it away. And finally it will slow down and you will see the grand finale. Well, actually it's just the beginning, but of this very long and boring and dirty process. You see all that black plastic stuff? It was all over my bench, and it's you know, it's attracted to static electricity, so this was horrible. Next thing I did was to prepare the outputs from the transistors, and where I connect the LED strips to. So I needed a way to connect the pin header from my controller PCB to a 15-pole D-sub connector I was going to use. And as you can see, there are 14 poles on that pin header, while there are 15 on the D-sub. So I am using 12 for the actual outputs, 2 will be for ground, and then I have one more pin unaccounted for. You see it in the bottom right corner on the D-sub connector. That will also be just jumper to ground, so it will be 3 pins ground. Here I decided to glue metal standoffs to the base of the enclosure, so I had something to screw the board into. I mean, I needed to attach it somehow to the inside. I thought about using screws from the bottom up, but I'm not sure how much they would, the screw heads would maybe scratch the table, because the little rubber feet weren't very big. So I thought I wanted to try just using epoxy. So I just attach the board to the inside here using epoxy on the standoffs, and I then push them down onto the inside of the enclosure. And then I remove the screws so they won't get stuck in the threads. And I remove the board, and this is what it looks like when they're in place. Of course, that will have to cure for a day or so. So this is one point where I stopped working on this for about 2 days while I let this cure to make sure it would sit properly. which it turns out it didn't, but that's a later surprise. Here's just some footage of me attaching the D-sub connector I was talking about earlier, which will be the I/O, the inputs or the outputs, whichever way you want to see it, because it syncs current. Here I'm just checking a DC jack, and I find out that the outside of the jack, the sleeve, does not connect to any of the three pins on the inside when there is no plug connected. So I had to connect the plug to actually see which one goes where. And then it was just a matter of soldering the wires to the DC jack. And when that was done, I used the nut that came with it and attached the DC jack to the case as well. And here you see me attaching the ground cables and the actual pin header for the outputs. And this is now 2 days later, so the epoxy has cured and I'm able to actually screw down the PCB and attach it. And next up is the MIDI connector. Nothing exciting going on here really. Sorry. Just cutting away one of the cables. I was thinking of using some sort of shield internally. I know you shouldn't connect a MIDI input shield, but you could still shield the actual wire on the inside as long as it doesn't connect to the cable shield. So here I'm just digging through my bags and boxes of nuts and spacers and whatnot, and trying to attach the MIDI jack. And there you have it. All the connectors in place. Now I need some buttons. I decided to use a small strip board and 3 of these buttons I had. And I also have the actual, the tops for the buttons. I have different colors. And I'm thinking of using the same technique here with using metal standoffs and gluing them to the inside so I don't get any screws sticking out just next to the buttons on the outside. Though I have decided to use screws for the LCD. Now I had some design mistakes in my on my board, so now I'm just cutting one of the traces. I didn't plan all this very well. I hope I learned some things from this, but I was going to use 4 buttons, but I didn't have any power supply in that connector, so I realized that I could only use 3 buttons because one of the I/O pins on the microcontroller, I couldn't use that one, so I could only use 3 buttons, which is fine because that left me with 1 extra cable that I could use as a power supply for these buttons. So there's a pull down, and then the buttons normally give 0 on the inputs, and when you push them they will give 5 volts. So I'm just showing you some boring soldering work being done, jumping the 5 volts to every button, well, all 3 of them. I'm just checking that it's okay, and the actual cables from the connector that I will use to connect the buttons to the PCB. So power first, and then the 3 cables for the 3 buttons. And that's that. So the display. I had a lot of problems with it because if you look at this, one of the screws prevents the connector from going all the way down. I didn't think of that when I designed this, and it's very annoying. So I decided I'll only use 3 screws. It's kind of ugly and it looks cheap, but yeah, it will have to do. And I'll just use these 3 buttons for these 3 colors for the buttons. So that's what it will look like, plus screws for the LCD. So time for some more epoxy. If you noticed, I was using latex gloves last time I was mixing the epoxy and applying it. But this time, well, I realized I wasn't getting any on my skin. Of course, to prevent accidents, you might need gloves, but I just skipped it this time, and I didn't get any epoxy on my skin. I don't think it will kill you instantly, but it's certainly not recommended. It contains a lot of nasty stuff. If you read on the package what the epoxy glue contains, you will see some familiar chemicals there that there has been some talk about. Bisphenol A, among others. And this is after a couple of days when the epoxy is cured. And as you can see, it's really looking like it's really solid and like welded onto there. And I didn't have any problems with the buttons. But the other epoxy standoffs I had problems with. But first I had to screw the LCD in using a plastic nut here. And here I run into another problem, which you will hear when I slow the video down. Listen carefully as I tighten this screw. What was that? Sounds like something cracked. Was it the case? No. Back side of the LCD? No. Nothing on the glass. Maybe the glass cracked? No. I'll have to remove it. You can see I jumped a little bit when the sound came. I wasn't really prepared for it. And this is what happened. You see to the right? That's the power for the backlight for the LCD. As the case pushed down on these on the backlight connectors from the other side, the soldering joint cracked, and well, I now have to resolder it, but since there is solder mask on the tracks, I have to get rid of that first, so I'm scraping it off. Yeah, you didn't see that, but that's what I did, and now I'm just putting some solder on there. So now the connector is already pushed all the way in, so hopefully, yeah, that wasn't very good, and hopefully it won't make any problems. Yep, just checking that the backlight works by applying some voltage to it, and then screwing it all back in. This is one of the unforeseen problems actually. And I still have the problem with the screw. I can only use 3 screws, but it will have to do. And I am now also attaching the buttons, and this is the connector for the LCD and for the buttons, and now it's basically done. This is what it will look like when it's finished. And I haven't really tested it since I had it as a bare PCB. So I am plugging a DC plug into the jack now, and I will just power it up to see if it still reacts and seems to work. So I'm feeding it 5 volts there, and as you can see, all the functions seem to be there still. And yeah, you can see the horrible the cutout for the display. It's not really even or smooth or straight, but there's a display at least. And the functions, yeah, I'm just stepping through the menu, so to speak, to see that everything seems to work, and it does. And I realize that increase and decrease had the wrong color. I like decrease on red and increase on green, and they were the opposite. So I just switched. These are just screws for the plastic enclosure, so I can close it up so it won't fall apart if I lift it. And that's basically the controller box done. Nothing more to do with it. But as you will see later, I will open it again to see what's inside and how I have connected stuff. So, controller is finished, and I've decided to test the outputs a bit. Not only to see if the display wakes up and works, but also to see if the actual outputs do anything when I press the test switch. And yes. So you maybe you noticed that not all the LEDs lit up, or all the strips, but I just pushed those cables into the D-sub connector, and yeah, they didn't make connection, and I only used half of them. So here I'm trying another enclosure, another plastic box, to see if the PCBs will fit side by side, or can I put them on top of each other, or kind of arrange it a bit, but I couldn't find any way that would make them fit. So I found this, an old VHS cassette with the box, and the box is what I'm after. Out with the tape, off with the cover, and you see that this is almost perfect actually. It's a little bit wide, but it's good. So I need a way to get these strips on the outside while keeping the PCB with the resistors on the inside. So I have to make a cutout in the back of the case. So just some rough measurements to make a hole that isn't all wrong, and some markings. And I thought of using a knife this time, because this plastic is kind of soft, so it feels like I should be able to cut through it fairly easily, but at the same time it's very tough, So it actually took quite a while to make this cutout in the back. And I switched to an X-Acto knife here and just repeatedly score it, and I got deeper and deeper each time, and finally I punched through, and you can see, well, now you can see I'm all the way through. So very boring, very tedious. That was easy because that was in the fold, so that plastic was very thin. Now I can put these through the LED strip cables, and it will look something like this. That's the best I could come up with, actually. Now, they are loose, these boards. I want them to stick together. I want it to be like one long board. So I was thinking I could use some old resistor legs and just solder across like a component to kind of brace the two PCBs together, like so. And that's only one, so I did a lot of them, and it looked like this in the end. Yeah, I saw someone else doing that, and I thought that was kind of clever, actually. Really simple, but effective. And now it's time to fasten the LED strips to the outside. I'm just assuming that this cover is that the plastic is clean because it's been behind the cover all the time. Maybe I should have wiped it off with alcohol or something, but it's kind of the surface is rough, and the adhesive on these LED strips isn't the best. It says 3M if you see on the tape there. So I guess the adhesive should be good, but on some of the strips the protective tape there was loose, and the adhesive had started to dry out. But I mean, this is nothing professional or something I will present to someone. It's just a way to keep this whole thing from just falling apart or, you know, breaking when I'll just put this in my bookshelf. This is what it will look like. Sort of straight, and yeah. So just to keep it secure when I stash it later. Now for the D-sub connector on the rear of the controller, I'm going to connect a cable to this amazing VHS cassette box. So I need to make a cable with a D-sub connector with 15 wires. So I am slicing there a bit, or separating the individual wires. And there is some heat shrink tube I'm going to use. I'm not going to remove this the single core wire that's already soldered on there. I'm just going to make use of them to solder directly to the ribbon cable. So I put the heat shrink tube on there, and now I forgot which pin on the connector is what. So I'm opening this thing and trying to see which one is C, which one is C sharp, which ones are ground, all that stuff. So I'm measuring and testing, and now I see the PCB has come loose. It doesn't show very well, but I get very angry. It's annoying. I think all but one of the metal standoffs that I screwed the board to, the epoxy has come loose from the plastic. But the ribbon cable from the D-sub connector keeps it in place anyway. So I just made note of which pins were ground and where C and C sharp and D sharp were, and then it just goes on in a pattern like that. So now that I know which pin goes to which wire, I just have to make sure I connect them in order. So these are the 12 notes, starting with the B or H as we call it, and working my way down towards C sharp and then finally C. This is, I don't mind doing this because it's simple. It's just soldering two wires together, and then you know, it's boring, brainless mechanical work, but I know what to do, and it's easy to do it. I don't mind doing this kind of things. What bothers me is finding boxes and drilling holes and cutting out holes and making cutouts, finding parts that fit. Those things really can make me not want to do something because I know I'll have to go through this part. But these little things, I kind of enjoy them actually. So even if it's a lengthy process, I don't mind doing it. So that's all the LED strips. Now I need to get that ribbon cable out of the box somehow. So time for the knife again to make a hole, or actually just a cutout. Just cut straight down. There's no point in trying to make a round hole or something. This will be just fine, and even better since the cable isn't round. However, I realized the DC jack is round, and maybe if the distance is fine, I can just use that cutout for the DC jack instead. So I did, and I made another cutout for the ribbon cable. And as usual, I don't remember which pin is what on the DC jack. It's the exact same type that I use for the controller box. And I keep forgetting which one is which. This is the third time I'm checking it. And finally, I'm attaching the this is 12 volts. This is for 12 volts. So I'm attaching 12 volts, it's the white cable, and then the 3 ground cables from the ribbon cable. 3 ground wires from the ribbon cable go to the DC jack as well, and there I have the power supply. And now I'm making strain relief by just tying a knot and making yeah, just to prevent the ribbon cable from being ripped out of the case if I'm a bit careless. And I didn't think of slowing this down. Maybe I should have, but I'm just testing that it works. And this is the first time I'm trying them both, and all of them light up. The LED strips all seem to work and respond, and that's very, very good to see after all this time. Doesn't it look nice? I love those colors. I could have made the what you call it, the color shifts a bit smoother, but yeah, I'm really happy with how this turned out. Okay, so this is the final test of my blinky thing, and the cats don't approve. Let me connect power to the controller. Seems to work. And let's start our favorite song. Yeah. Right. Now, to check if this still works. Yes. Fade out time works. Maximum fade out time. Something not working there? Didn't seem right. You know what? I'm not gonna bother trying to fix that. Everything seems to work fine anyway. And I think I'm done with this project. So I hate doing enclosures, mechanical stuff, trying to use epoxy to attach nuts to the case. It's the standoffs, I mean, they wouldn't stick to the plastic with the epoxy on the inside. The PCB came loose, but I don't care.